Hey kids, here's where the fun begins. We get to take all those things that we've been talking about with derivatives now, and we get to totally dump that whole long, ginormous limit process and just get right down to the nitty-gritty. So we needed that limit process to understand what was going on, but now we don't have to use it all the time. We've got all these different tricks now that we can use, and we can start putting them into our bag of calculus rules, which is going to grow exponentially, but it's just is going to make life really nice. So take a few minutes here as we go through this and just look at some of these wonderful things we can do now without having to take a limit. First off, if f is a function that's constant, then the derivative is 0. So if I tell you that f of x is equal to 4, then f prime of x is equal to 0. Remember, we're dealing with rate of change. And if the rate of change is constant, that would be 0. Okay, there's no rate of change. All right, what about the power rule for positive integers of x? Hey, now this is one that some of you guys should have maybe seen or caught a glimpse of somewhere along the way as we've been working, but f of x equals, let's say something really tough like x to the 4th. So if I go x to the 4th and I want to know what f prime of x is, all I have to do is take that 4 that's up in the exponent, put it down here in the front, rewrite my variable, and subtract 1 from 4. We can do that. We're in calculus. So 4x cubed is my new derivative. No more limit process. Gosh, this is great. Well, what about if we have some function u and it's differentiable and c is a constant, then what? Well, that would be something like this. If f of x equals, say, 3x to the 2nd, okay, then we have a constant, and that constant in this case is the 3. So we would just take the 3 times the derivative of x squared. Well, what does that look like? Well, that's a great question. So this would be f prime of x equals 3 times 2x. That 2x is just like what we did a second ago. So what is this really? 6x. Okay? So all we're going to do is take that exponent now and multiply it with the constant in front. Oh, this is so much easier. If u and v are both differentiable and their sum and differences are differentiable, then we add the derivatives. What does that mean? That means if we've got a polynomial, say f of x equals 3x squared plus 7x, the derivative then, we would still just add those up. It's still going to be the exact same thing. So what's the derivative going to be? It's going to be 2 times 3, 6x, just like we had on the previous problem, plus the derivative of 7x. Now, what would that be? Just 7. And these are the first few rules that we're going to have in a long line of rules this year in calculus. And man, do they make life easy. Okay, so we just took a peek at some of the basic rules and how to use them, and here's a little bit of a more complicated problem now. Find dp dt if p equals t cubed plus 16t squared minus 5/3 t plus 16. Yikes. A lot going on here, but not as much as you might think. We're just going to go ahead and take the derivative of each guy along the way here. So what we would look at is dp dt would end up being, however, let's see, would be p prime. Wow, what's going on here? P prime is equal to 3t squared plus 12t minus 5/3. And remember that the derivative of a constant is 0. And that's all I did. All you're going to do. That's all there is to it. Do you see the pattern? 3 times the number in front, which happens to just be 1. Subtract 1, that gets me the 2. 2 times the number in front, 12. 12 times t to the first power, just t. This one that may be a little tricky is negative 5/3 t. Remember, this is t to the first power. So when I take that 1 up there and I I multiply it by negative 5/3, I still get that negative 5/3, okay? But what happens is my t now has 1 minus 1 as its power. So this is negative 5/3 t to the 0, which is going to be negative 5/3 times 1. Anything to the 0 power is 1. Okay, so that should be the only one that maybe is just a little bit on the tricky side, but again, it's totally doable. Well, what about finding horizontal tangents on this curve down here, x to the 4th minus 2x squared plus 2, and all the points where they occur? Now, this at first looks really daunting, but we just need to know what y prime is. Remember, if we can find a derivative, we can find an equation to find all the tangent lines, okay? And so what's my derivative for this? Well, 4 times 1, that's 4. And then 4 minus 1, that's my power, is 3. Minus 2 times 2, well, that's going to be 4. And then x squared is just x. Okay, again, no problem. And then 2 is just going to be 0. So here's my derivative. And now the question is, find all the horizontal asymptotes. What does that mean? That means that we're going to have a slope of 0. So what am I going to do to find where all those things occur? Well, if I want a slope to equal 0, then I set the derivative equal to 0. It's going to look like this. And then solve this guy out. And again, he looks really hard, but just go through and practice some of those Algebra 1 skills that you've got, and he actually turns out to be not too bad. Factor out of 4x, and we're left with x squared minus 1 equals 0. And then look, x squared minus 1 factors. So 4x times x plus 1 times x minus 1, that equals 0. And then you can set each piece equal to 0. So 4x equals 0, x plus 1 equals 0, and x minus 1 equals 0. So where do we find all of our horizontal tangents? We find all of our horizontal tangents at these spots. When x is 0, when x is negative 1, and when x is positive 1. That's it. Life just got so much easier. All right, so we've looked at some really basic rules on how to take derivative by taking that exponent and multiplying it by the number in front and subtracting 1 on the exponent and all that kind of stuff. Well, things change just a little bit when you start multiplying, because now when you multiply, you got different things going on, okay? And you don't just have plus or minus anymore. You've got all kinds of stuff that could be happening. So we've got a rule for that. And our rule says that if we're going to take the derivative of the entire thing, okay, so we've got some function u times some function v, and if we're going to take the derivative of that, then what we're going to do is we're going to take the derivative. We're going to take the first function times the derivative of the second, plus the second function times the derivative of the first, or if you look at it this way, we're going to do u times v prime plus v times u prime. Okay, that's not first power, those are primes, meaning derivatives. So kind of how does this work in action? Well, it works this way. If I've got x squared plus 1 here, and I've got x cubed plus 3 here, and I want to take the derivative of f of x, which are these two things multiplied together, then all I need to do is take the first term, so f prime of x, let's get some different colors going, f prime of x is equal to the first guy, x squared plus 1, times the derivative of the second guy, and the derivative of x cubed plus 3 is 3x squared, and then plus the derivative of the first guy, which would be 2x, times just the second guy, x cubed plus 3. Now, don't leave it this way. You're not quite done yet. And if you are taking a quiz or a test and this is where you stop, you've done most of the work. But this is actually a problem we can organize out a little bit better, simplify down, and just make prettier. So go ahead and distribute in this first part here. That's going to give us 3x to the fourth plus 3x squared plus, and then go ahead and distribute on the back end here, 2x to the fourth plus 6x. And so now I can combine some like terms together, like 3x to the fourth and 2x to the fourth, and that's going to be 5x to the fourth plus 3x squared plus 6x. And when I get done with that point, that is when I'm done with all of my work. Okay? And so you might need to watch this part a couple times. It's totally doable. It's a little bit different. You just have to pay attention. What's multiplying with other stuff? Because that's going to tell us what we take derivative of and when. Okay, so now let's look at the division aspect of this. What are we going to do now? Well, with division, we have to follow a little bit of a different set of rules. And so this is called the quotient rule, and you're going to hear it a lot, just like with the product rule from the previous slide. So one thing we need to make sure of is if we have some function divided by another, that bottom function, it cannot equal 0. If it equals 0, we can't do anything because at 0 in a fraction we are undefined. So what we're going to do is we're going to look at this function divided by another function, and we're going to use this rule where it's kind of complicated and weird looking, but we're going to like take v times the derivative of u minus u times the derivative of v all over v squared. And so that's what this guy looks like. There's a couple of other ways to think of this problem, which may or may not help you. We could look at it as v times u prime minus u let's get rid of that guy, u times v prime all over v squared. This is one way we could look at it. Or we could look at it this way, and it's the same thing, but it's a little bit different. It would be something that we would call low d high minus high d low all over low, or low squared. Okay? And these are the two different ways maybe that you might be able to remember how the quotient rule works. So it's a little bit challenging, quotient rule is, but after you've practiced it and done it and worked on it and looked at it and messed with it, it does get a lot easier to do. And compared to some other things that we're going to do in calculus, this actually isn't so bad. So we want to find the derivative of x squared minus 1 over x squared plus 1. And how do we start that? Well, we're just going to remember that on top is u and on the bottom is v. And I'll tell you what, I'll make that v a different color so that we can see a pattern here. So we'll make v this color right here, v. So I've got u on the top. So how's this going to work? Well, u on top, v on bottom. I'm going to take low, so f prime is equal to low. That would be x squared plus 1. And always use parentheses, or else you're going to have an error. So low d high, that means the derivative of the top, which is 2x, minus high, okay, and then again parentheses, and that's going to be x squared minus 1. D low. D low is going to be 2x all over, whoops, I want black ink for that part, so we'll just get the black ink part here, all over the low man squared, low. So x squared plus 1 squared. Now, you've done most of the work. However, you're not finished. We have to clean up the top. So on the top, I'm going to have 2x cubed plus 2x. That's the left-hand side of the top. Minus, and then on the right-hand side on the top, in parentheses. Don't forget those. You're going to have 2x cubed minus 2x. And so this is what you've got going on the top. Well, now let's combine together all the things that are the same. So on the new problem that we're going to end up with is 2x cubed minus 2x cubed is 0. Easy enough. Plus 2x plus 2x is 4x, not 4x squared. Okay, that's a very common mistake. It is not 4x squared, it's just plain old 4x. Why? Because if I have two x's and I add two more x's, I've got 4x's, and that's what we're dealing with on the top. On the bottom then, you don't necessarily need to square this out. You certainly are more than welcome to do so. Don't make an error in the process, but x squared plus 1 squared is fine because nothing reduces. So this is using the quotient rule. It is a little challenging at first, but after you've worked on it and noticed what these patterns are, it does get easier to do. All right, we've looked at all these different rules. Here's a couple of theory type of questions using these rules and trying to figure out exactly what their style is, how they work, can I recognize some patterns? So they're telling us that we've got two functions, u times v, and they tell us to find y prime of 2 if, and then they give us these rules, and they tell us exactly what we need to know. They say, hey, look, I know a value of u, it's going to be 3. They say, hey, look, I know the value of u prime, it's going to be negative 4. They go, hey, look, I know the value of v, it's 1. And oh, by the way, I know the value of v prime, it's 2. So we've got all of this information right here. Well, how do you find the derivative of two things multiplying together? So if I want to know what y prime is, then I'm going to look at u times v prime plus v times u prime. And we've been told all of that information. So I'm going to look at u. That's not the right color for u, is it? So let's get that guy out of there, and let's find the right color for u. We're going to take u, we're going to take u, and I keep putting them on there. Sorry about that. And u is equal to 3 times v prime. V prime is this pinkish color. So when I look at v prime, that's this pinkish color over here too. U times v prime plus. And then v, which is in purple. V, which is in purple. So v, which is 1, times u prime, which is negative 4. And so when I work this out, I'm just going to have 6 minus 4, which is 2. And that's your answer. That is the derivative at 2. And that's using your rule for how to find derivative of a product. Okay, so now we've got this cool rule that we can do anytime we have a negative exponent. And it works exactly like the rule did when we didn't have negative exponents. And all we're going to do is whatever that number is in the exponent, we're just going to bring it down and multiply and subtract. So if I have something like y equals 3x to the negative 2, the derivative is negative 6x to the negative 3. Why is it negative 3? It's negative 3 because negative 2 minus 1 is negative 3. This is calculus mistake number 26. Anytime you have a negative exponent and you subtract, you actually have a smaller number than where you started. So don't say negative 2 plus 1. That's a no-no. And we're trying to avoid those at all costs. Okay? So what do we got? We've got negative 6x to the negative 3. Well, check out our problem. Check out our problem. We've got y equals x squared plus 3 over x. They want us to find a linear tangent at the point 1, 2. xy, 1, 2. Okay, so find an equation for this curve. What's it look like? It looks like this. Number one, this x down here can be rewritten into the numerator with a -1. Don't forget that little rule. Any exponent can go from the top of the fraction to the bottom, or the bottom of the fraction to the top, by making that exponent an opposite of what it currently is. So what problem am I really dealing with here? We're actually going to work on this problem. X squared plus 3 times x to the -1. And when I work on it and look at it this way, I have u and I have v. So now I can use the product rule and life gets nice. So what's the product rule look like? Let's just remind ourselves real quick. So I'm just going to come over here and help us remember that if I have u times v, the product is u times v prime plus v times u prime. Okay, those aren't ones, those are primes. So what does this look like for us? Well, so all we need to do then is we just need to look at how we've got u and v set up and then use our product rule. So what's the derivative, what's u going to be? Well, it's just going to be x squared plus 3. What's the derivative of v? Well, the derivative of v is going to be negative x to the -2 power. That's it. That's all we got to worry about. And then plus the derivative of u, which is going to be 2x, okay? And then times v. Well, what is v? Just x to the -1. So when I simplify this all out, all I have to do then is just go through and multiply things together. And remember, if the bases are the same, in this case they're all x's, I can add the exponents together and that will give me my final answer. So negative x to the -2 times x squared. If you multiply those together, that's going to be negative x. And then when you, let me get a black color here. That's going to be negative x. And then -2 plus 2 is 0. Okay? Now hang tight. Don't panic yet. Minus 3x to the -2 plus, and then over here on this side we're going to have 2 and again times x to the 0 because -1 plus 1. What does this mean for us? That means anything to the 0 power becomes the number 1. Anything. So what we're going to end up with is -1 minus 3x to the -2 plus 2, which will give us for a final answer -3x to the -2 plus 1. Now, this is a good answer, and this is what our derivative looks like. But sometimes you will run into a teacher or a professor who doesn't like to see a negative exponent in the numerator. And if that's the case, we just really easily move that sucker back down to the denominator. And when you do that, you have the opposite value of your exponent. Okay, so both of these answers right here for me are good answers, but again, pay attention to the instructor that you have and how they exactly want the answer written. All right, so now we've got this derivative, we've got it all cleaned up, we know exactly what it looks like. The question is, how do we find the equation of a linear tangent at the point 1, 2? Well, easy. We have a point 1, 2. We have an x value 1, and our derivative gives us the slope of a tangent line. I mean, it doesn't get any easier than that. So what we're going to do is we're just going to take that 1 that we've got for our x-coordinate, this bad boy right here, and we're going to plug him into our derivative right here. So everywhere we see x, we put in a 1. That's going to give me right here negative y equals y prime equals -3 over 1 squared. So here's what it's going to look like, and it's going to give me this guy. And oh, by the way, the derivative is the slope, so I have a slope and a point. What's that give me for my final answer? It gives me y minus 2 equals -3 times x minus 1. If you didn't want to write it that way, you could move the 2 over so that you have y equals negative 3 times x minus 1 plus 2. I would stop there. You're not always going to get a really pretty slope like negative 3. Sometimes it's going to be a fraction. And you know what? This is the equation of a line, and that satisfies the question that we were asked. Okay? So that's all there is to it. It's a two-parter, and that's really it. It's kind of a fun, easy, much simpler way now that we can write the equation of a tangent line. Okay, finally the end, the last example problem. Okay, and it's one that's just kind of fun to do. So we're asked to look at some higher order derivatives. What does that mean? Well, we have a function y equals x cubed minus 5x plus 2. Then the question says find the first 4 derivatives. Well, what does that mean? That means we're going to take the derivative of the function and get an answer. And then we're going to take the derivative of the derivative. And then we're going to take the derivative of the derivative of the derivative. And so on, as you can see. So it's actually pretty simple. We're going to use our cool derivative tricks. And on this guy, y prime is equal to, wow, that's a nasty looking 3. Let me just clean that up a little bit. Nobody wants to take that home on a Friday night for a date and meet mom. So 3x squared minus 5. There's your first derivative right there. That's all there is to it. Remember, 3 times the number in front, which is 1, and subtract 1 from the exponent. On the 5, since the exponent on the x is just 1, that's all it is. And the 2 becomes a 0. So now I've got y double prime. What does that look like? Well, take the derivative of the derivative. 3 times x squared minus 5. That's going to be 6 times x minus 5. There's the second derivative. No problem. What about the third derivative? Same thing. So I'm going to have y triple prime. 1, 2, 3. Y triple prime. What's that look like? 6. I know, you think there's more there, but there isn't. What about the fourth? Y, the fourth prime, the y to the IV. Well, how does this guy work out? Again, just take the derivative, but 6 is a constant, so the derivative is just 0. And that's all there is to it. And that's the first 4 derivatives. And life now is nice, and we can start using all these tricks that we've seen with this lesson, and it just makes the whole limit process go away. And now derivatives are our friends. So good luck, and just hang in there and be patient while you're learning these new rules. Hey guys, just a little fun thing. I want to see how much participation we get, so I'm just going to drop off a word here on the screen. And if you happen to see what this word is, go ahead and go ahead and reply to the assignment in Edmodo. Complete the assignment, and where it asks for an answer, just type in the phrase that you see here. And I don't know what that is. Let me get rid of it. So just type this phrase in, and let me know what it is. Keep it secret though. Like, don't tell your buddies. Let them figure it out on their own.